hello, hello. Hello, hello. Hello, hello. Hello. Hello, is this Miguel? Hello, hello. Hear me?
Oh, hi.
Hey, is this Miguel?
Hi.
Hello, hello. So I'm talking with Miguel Martinez, right? I think you're shutting down.
Yes, I can hear you.
Okay, perfect.
Yes,
Okay, so are you ready to start?
yes, I am ready.
Okay. So I'm going to explain a little bit what we're going to do in this interview. So we're going to spend the first 4 minutes to introduce ourselves. Then we're going to have a coding exercise. So I'm going to ask you a problem. Then you're going to try to bring up a solution. Then I will give you a couple of minutes at the end of the interview for you to ask me some questions about the company, about my work, or some questions you might have. So
Okay.
okay, perfect. So I'll start introducing myself. So I've been working at Microsoft for 2 years now. I've been working mainly on the backend systems, mainly building a tool which basically helps our users to track all the bugs information. So yeah, basically I'm all working on Azure technologies, uh, basically using a lot of a C# there, a lot of acoustic clusters, and yeah, a lot of backend technologies right there. So do you want to tell me something about you?
Um, yes. Well, I don't know. I can talk to you about my general trajectory. I have since middle school. I have been working on my mainly on pure mathematics. So I have a strong interest and a strong knowledge base in that area, and I just and then in high school I kind of transitioned into more of computer science trajectory. Um, in that space of time, I worked in various projects. I started connecting dots with that area. Uh, I developed a strong interest in compilers, for example. And and it was just very recently that I also started my journey in competitive programming. So in that, it was mainly in that span of time that I started to work more closely with algorithms, with studying that area of mathematics. So yeah, I can say that I am mainly oh,
don't worry.
Yes. So basically, I have a very strong theoretical background. I have obviously have had some practical experience during my years at high school because I attended a technical high school specialized in computer science, and I am currently studying at the Escuela Superior of Cómputo. So yeah, I think that's it.
Okay. So yeah, I was taking a look at your resume right here. So I see you have 4 projects right here. So would you like to tell me what project was the more challenging for you and why?
I think that it was the first one. It's kind of like a very significant milestone in my development, I think, because I barely had any kind of knowledge about data structures in that time. I was in high school, and I was just starting to know about like trees, lists, and all that kind of stuff. No, but I was very confused. I was extremely confused about all of those things. For example, I just for a list insertion, I remember that I did it in linear time complexity instead of constant time, because I thought that to insert a node you had to go to the last node. So I was very confused at that time, but I was also, I think that with a strong creative force, and with those tools that I had, I started to imagine how you could compute something more abstract, like a derivative.
Oh, I see.
Because, well, a derivative is, it's kind of a very it's kind of simple once you know the rules how to do derivatives. You just kind of have to apply the rules over and over again to get the result. So I felt that it was something that a computer could do. So I set my mind to it, and I started creating some ideas about how I could do it. I was even challenged by my professor because I talked about my idea with him, and he thought that I couldn't do it, but I did. It had a lot of bugs. Sometimes it crashed kind of randomly, but it was very significant. It did most of its job in being capable of derivating any kind of expression with any kind of complexity. And you could also plot it.
Oh, I see. That was a very interesting project from you, Miguel. So do you feel ready to go to the programming question?
Yes.
So you have a background in mathematics, so I'll try to put a problem related with that. Yeah, so at least it has to do with numbers. So let's say I'm going to give you some numbers. 2. I want you to return the next greater number, which has the same amount of bits. So basically, for example, you can have this number 2 as input, and then the output for this one is 4. Did you understand the idea here?
Yes, I think I understand. So you just have an n, and the n has obviously a bit representation. Let's say I0, I1, I2, what is that? A n, no? in which every A is either 0 or 1, and it represents that number, no, in binary. And basically, you're just talking about the number of those A's that are 1. That is what you refer to as the number of ones in the representation. And then you want another number that also has that, let's say that it's M, and it also has the same structure, and the number of ones, that is to say, like the sum of all of those bits, it's equal to this sum, no? And this number has to be the minimum one that is greater than the n given.
Exactly, yes.
Okay. Okay, let me think about it a little bit. I'm just kind of picturing it. The first image that came into my mind was when all those bits were kind of clustered, like in just in one fragment. And it was kind of clear to me that in that case, you would just need to move the less significant bit to the other part of the block. But obviously, I'm trying to extend the idea. Okay. Okay, yeah. I think that it very cleanly extends to any other number, because every number can be represented as kind of every binary representation can be also represented as a kind of sequence of different blocks, like if you have this number, least significant digit is here. You can kind of think of it as a group of segments that are ones, then segments that are 0, segments that are 1. And it was kind of obvious to me that the solution for this, for a single block of ones, so if the representation of this number was something like 111 many times, then only zeros, it was kind of clear to me that you just had to move like the least significant bit in this block to be in the next one. So for example, you have this block, and to get the next one that has also 3 bits, you would have to move this bit that I marked there. And you would move it to the end of the block. So something like this. I put the 3 ones. And then the 0, that was the previous position of the 1, and then only zeros. And then this one is kind of clearly the first one. Let me think.
That for sure is a greater number, right?
Yes. It's very clearly the greater, but I'm just kind of No. I'm very, very mistaken, I think. Yes. For this block, the solution would not be this, because though these bits do not need to be here, because already by being this bit on, it would be a greater number, and then these bits don't have to be here, no, at all, because these bits are kind of free to be anywhere. This number is already greater, so the bits can be here. Okay, so I was completely wrong. That was kind of my intuition at the first glance, but I was wrong. But I think that the extension to the mini blocks, it's not changed almost at all. I think it maybe just it would be yes. So okay, I am pretty sure about this because no. Also, no. This has to be here because this cannot. So the way that I think I'm sure is if you let the most significant, obviously the most significant digit has to be greater than or equal the most significant digit in this one. And if you let it be here, and you let the other ones be at its right and not be in this position, then it would be a lesser number, no? So, for example, this is less than this. So you must put the most significant digit in the next one. By that reasoning, it is completely required. So if you already put one in here, you already know that this number is greater than this one, even if it didn't have any ones. So the ones are kind of irrelevant, but you have to have them to obviously to be according to the requirements. So for you to put the remaining ones in positions that are less that are of the less value, it would be like this. You just put them at the end.
Yeah, this solution makes sense to me. It looks pretty extra, right?
Yes, it would only depend. Well, I haven't talked about how the idea extends. Well, I think it's very direct, but I will just talk about it very briefly. Also to think if there are any counter arguments. So this reasoning was for only one block of ones, but obviously an arbitrary number does not have to have only one block of ones. So the general structure of a number could be seen like this. And the idea is to just apply this idea to the first one block of numbers. So, for example, if you had this kind of structure, I would apply the idea to these last one groups of bits. And I'm pretty sure that there's no problem with extending the idea. Because the only thing that could change here is maybe there was not enough space to put the next one, no? The next bit on. But by my definition of blocks, there is at least 1 0, so there shouldn't be any kind of problem. So I think that this is my main. This is the idea that I would go for. Yeah, and it only depends on the on the number of digits that the number has.
Okay.
So yeah, obviously in the number of binary digits, because we're talking about binary digits. So yeah, it would be like log base 2 of n kind of process. And I would be very very happy with it. I didn't even think about boundaries of n because if we are talking about digits, it kind of I was sure by intuition that the best thing that I could do was something like this. So yeah.
All right. Yeah, this solution looks nice to me. The other one would be just to apply brute force, right? Just iterate through the numbers and check the amount of bits. But your solution looks to be faster than that one. So what do you think we go ahead and try to code your solution?
You're talking about like a very brute force solution, like going, like incrementing the number and checking the number of bits. Okay. Yeah, yes. It would be like the most direct idea, but my mind kind of immediately went to think about the most efficient, and I so I did. Okay, I have to write the code here. Yes.
Yes, please.
Where is the monospace? Okay, how do I write the thing? Do I need to read the input? Do I just make a function that does the thing?
Yeah, let's just write a function.
Okay.
You can name it whatever you want.
Okay. Do we think that our type is known, not or numeric type? Could I just think that it is int, or is it wrong?
Yes, let's say it's an int.
Okay. Okay. Now I just have to think about how I would implement this idea.
Mm-hmm.
So basically, I am thinking about doing a process over n to, in the first place, get the factorization of the number, let's say, in these two big blocks. So this will be like a big block, and this is the block in which I am interested.
Okay.
And I am just thinking about a process that gets these two components. Obviously, there is a special case in which the number is 0, in which it's kind of funny. I think the solution does not exist. So I think that I would also assert that n is not equal to 0, because if someone calls this with 0, he cannot have a number greater than 0 that has then 0 number of digits in 1. So it's impossible. So this function shouldn't function at all with n equals 0, I am sure. Obviously, we are also thinking about only positive numbers, because I think that if we talk about negative numbers, it kind of has a strange meaning if you want to get this number. Am I correct in this assumption?
Right, yeah, you're not going to receive 0. So
Okay.
there's no even need for your research, but it's good to have.
Yeah, I think that this is just good practice, because if someone calls at any moment this function, then we would know that the reason the code fails is because someone called this function with invalid arguments. So I always put these kind of things because I think that they are quite useful. So okay, we already know that n has at least one at least. So I will get the factorization. Let me think about how I would do that. Maybe to get this factorization, I would just to represent this right part of the factorization, I would just count the number of ones that are in the block and the number of zeros, because I already know in which order there are, and for this part I will maintain a number, like after the process that I am going to do, the number will be equal to this part of the block, and I would have extracted this information of how many ones are in the right part of the factorization and how many zeros are there in the right part of the factorization. To do that, I think that I would just do a very routine kind of no. I'm not sure about the condition, so I would just put this for the moment. I would get the current bit. Oh, okay, so if I just want to get like these, the first digits that are 0, so I will just get them while the first digit of the number is 0. And then just, so I am in this block and I have found the next 0. So I will increment my count of zeros, which I will have here. Count 0 will be incremented, and then we will extract that bit from the number, which we do it like this. And then to extract the next block, I would just do a very similar process, just with 1. The software is changing the capitalization, but this is obviously this n.
Okay.
And this is a while. And then after I have this, just need to think about how to do this. So the number I want to have at the least so the least significant portion of the number that I want to have has to have 1, then count of 0 plus 1 zeros, and then count of 1 minus 1 number of ones. It's kind of a structure that I want to have. I'm just thinking about how to do it kind of the most simple way. So the most significant one in the part that I am analyzing at the moment has at its right has count of 0 plus count of 1 number of elements. So I already know how to get that bit. So basically, I am already sure here that the number of ones should be greater than 0. So we already have a block. And then we can get the block length as just the number of ones plus the number of zeros. And then the most significant one that I want to generate has to have this number of elements at its right. So I am sure that this, let's say, transformed block has to have at least this digit. And then it has to have a less significant block of ones of count 1 minus 1 number of ones. So a way to make that is by kind of a simple bit manipulation trick, which would be like 1. We first move a 1 by count of 1 minus 1, I think. So 0, and then we need to be very careful about this parentheses, and then we subtract 1, and so this would be like the most significant one, and then the block of the remaining ones, I think. So this is just the part of the transformed block, and to get the complete number, I just have to combine this transform block with the number that currently holds the left big block that I was talking about. This one that I have marked. I don't know if you see it, but I'm talking about this big block. N already holds that. And to recover the number, I just have to move back those bits to the left, because now they have been moved to the right, and and then sum this new transform block. So what I'm talking about is concretely like I would just move this n, this number of bits, and then to the n I will sum the transformed block, and then I return this n. So that's the idea.
Mhm.
I am thinking about if I am missing anything. So, for example, in your test case, I'm trying to think about kind of concrete examples.
Okay.
In your test case, the idea is that it would take n equals 2, and then it would first extract this block. So the information that in particular it will get would be that it has only one 1 in that block and only one 0. And the length of the block length would be 1. No, would be 2. Would be 2. I put this wrong. The count of zeros would be equal to 1, and the block length would be equal to 2. So, an n after this process would be equal to 0 because we have extracted this part of the number of it's all the numbers. So it would be equal to 0 at this point in time. And then I am creating the transform block, which will contain the most significant digit at the block length. So it would be, I think that part would be representing this number, which is already 4. And I hope this part would be 0, because that part is supposed to represent count 1 minus 1 number of ones. And if you do that, that would be like 1 moved 0, because count 1 minus 1 is equal to 0. So that would be just 1 minus 1. So I think that it's correct, because that would be 0. So we are just adding 0. And then to get the full number, I am just moving the 0 block length to the left and then adding this transform block. So it would be at the end true that n equals to 4, and that is what I am returning from the function. So okay, for this case, I'm pretty sure that would function, and I am quite sure that this would work in general. Obviously, don't without thinking about like the very corner cases in which we are at the 31st significant digit. That would cost cause some problems, but I am just not thinking about that.
Okay. It looks like we have some time left. Do you want to go ahead and test with another case, or do you feel ready to go and ask some questions?
Uh, Let me give me some just a minute to think about the code, and I think that then I would be ready to go to the next part. Okay, I think I'm sure that this would solve the problem, and so we can continue.
Okay, so yeah, in this section, what you can ask me anything about the company or the culture or anything you have in mind, and I'll try to answer.
Okay. So when I was in the 2019 regionals, your company, I remember that gave a talk, and they talk about some things that I remember were quite interesting. It was more of kind of research work, and I got kind of hooked about it, and so I thought that maybe if I could get to work there, I would be very interested in to be like in that kind of area. So, do you know anything about how you, if I would be able to like move to that kind of area, to move to that kind of teams? Because the research part looked very interesting.
Oh, I see. That's an interesting question. So I'm not in the research area. However, well, actually, you're right now applying for software engineer, right?
Yes.
Probably you might not be able to start as a research employee, but I know of friends that have moved from the software engineering part to the research area and vice versa. So that's definitely something that can be achieved within the company. And you can contact these research teams and definitely showcase what you've done and your experience and your motivations just to join those kind of teams. So yeah, definitely, Microsoft has a variety of research teams like in different areas. So it's just a you just have to look for like the area that you want to go into, and yeah, just make some connections there.
Okay, so yeah, that's interesting because I was that kind of motivates me to go in that kind of job. Yes, I don't think, obviously I don't think that I would instantly could get to that kind of that kind of area, but I was interested how flexible it was to do that kind of movements once you are there. So thank you. That was a question that I had since then because it was very interesting.
Yeah, pretty interesting question. Do you have another question?
Mm. Um, I don't know if this kind of question is like. It's appropriate, but if I got the internship, how would the assignation to different teams work?
Okay. So what we usually do in Microsoft is that, based on your resume, we contact our teams and see if you're a good fit for them or no. So basically, we search you a team that matches your experience or preferences. So that's the simple explanation of how we match you with another team.
Okay. I don't know. I don't feel that I have any more questions.
Okay, this is great. I had a good time with you, Miguel. Thank you for coming to the interview. Hopefully, you get good results. Yeah, hope to talk to you later.
Thank you. Me sentí, es que bueno, al inicio, principalmente me bloqueé.
Sí, creo que sí lo noté un poquito.
Sí. Hay momentos en que mi mente se pone en blanco y...
A ver, allá abajo te pegué el feedback.
A ver. Lo estás escribiendo, ¿verdad? Sí, noté que lo estás escribiendo mientras.